Now let us move to next problem, and next problem is from the rotational dynamics, and we are going to discuss the concept of the angular momentum and torque. So let us move to the next problem, and in this problem it is given a student of the physics performed two experiments. In first experiment he take an uniform square plate and place it on the rough horizontal floor. This is the uniform square plate, and this blue color surface represent a rough horizontal floor. When he rotate the plate with angular velocity omega naught about a vertical axis passing through one of the corner, here in this case this is the corner and this is the vertical axis, and initial angular velocity is given omega naught and it takes t naught time to complete stop. If the second experiment, what happens? The same plate is taken. Okay. Now it is being rotated about this vertical axis. In this case the vertical axis is passing through center of the plate, and here we need to calculate the time when this plate will stop. Okay, we know the plate will stop due to the torque of the friction. Friction will appear in the lower surface of the plate. That means because of this friction this plate will stop. Now let us consider a plate of mass capital M and length small l. So let us make the plate. This is the plate. This is the center, right? Mass of the plate is capital M. Now let us rotate the plate about O. The vertical axis passing through O. Okay. Now consider one situation. If mass of the plate is greater will be the torque of the friction force. If size of the plate is greater will be the torque of the friction force. Now we can say the torque of the friction force is proportional to mass of this plate and size of the plate. In mathematical form we can write torque of the friction force about O is proportional to ml. Let this equation number 1. Now let us consider contribution of this torque due to 1/4 of the square plate. So let us consider this part of the plate. This is 1/4 of the plate. Okay, we can observe the 4 parts are symmetrical about O. That means the contribution of the torque due to this section, that is a 1/4 section of the plate, is proportional to ml divided by 4. It should be 1/4 of the total torque. Okay. Now consider only this part, this square plate, and if we make the center of this plate say O dash. So let us make the center of this plate O dash. We know size of the plate is L by 2 and mass of this particular plate or particular section of the plate is M by 4. That means if we rotate this part of the plate about O dash, the torque of the friction force proportional to M by 4 multiplied by L by 2. Instead of writing M multiplied by L, we should write here M by 4 and L by 2. That means the torque of the friction force about O dash is proportional to ml divided by 8. So let us write this torque. Now let us find the ratio of the torque about O and O dash. So we need to divide this equation by this equation, right? So we can write this ratio, this torque of the friction force in case 2 divided by torque of the friction force in case 3 is equal to torque about O divided by torque about O dash, and this is equal to 2. Let this equation is equation number 4. Okay. Now let us move to our real situation. Let us make the diagram of the real situation. This is the first case, this is the second case. We know both plates are identical. So here we can write the torque about O and torque about O dash should also have the ratio 2. So we can write the ratio equal to 2. Okay. Now we can write the average torque. We know the definition of the torque. Torque is rate of change of angular momentum, and average torque is delta L by delta T. We can write. So we can write average torque equal to delta L by delta T. Right. So here we can write delta L equal to final angular momentum minus initial angular momentum. So let us write first torque about O. Right. we need to find the value of moment of inertia about O. We know moment of inertia about this line. You can follow the motion of my pen tip. Moment of inertia of the plate about this line is equal to ml square by 3, and moment of inertia about this line is again ml square by 3, and perpendicular axis, from perpendicular axis we can write this moment of inertia is equal to 2 ml square by 3, and final angular velocity is equal to 0. So we can write this magnitude 2 ml square by 3 multiplied by omega naught divided by t naught. Similarly, we can write torque about O dash. This is I O dash and omega final minus omega initial divided by t. T is unknown, we need to calculate, and moment of inertia I O dash should be equal to moment of inertia about this line is ml square by 12. Moment of inertia about this line is ml square by 12. You can follow the motion of the my pen tip. So moment of inertia by perpendicular axis should be equal to ml square divided by 6. So let us write this relation. Now we can divide. Okay. Now ml square term will get cancelled. Omega naught will also get cancelled. This is equal to 2 by 3 multiplied by 6 t divided by t naught. We can further simplify. This is equal to 4t divided by t naught. Okay. That means the ratio of the torque should be equal to 4t divided by t naught, and we know the ratio of the torque is nothing but 2. So we can write 2 equal to 4t divided by t naught. That means t is equal to t naught divided by 2. This is the required time.
Dear aspirants, Cengage India has launched the new edition of our JEE Advanced Physics books. Please visit www.cengage.co.in to buy a copy. You can also buy the books from Amazon or Flipkart.